Alright, got another genuinely approachable Sudoku here from the Cracking the Cryptic guys. This one's called Determinant Sudoku. And I felt like I had to do it because I was just teaching my pre-calc kids matrices stuff, and this has to do with a matrix determinant. So normal Sudoku rules apply. So it's digits 1 through 9 in every row, every column, and every box, and they can't overlap. And then we've got the determinants of 2 by 2 matrices are given in the corner of 4 cells. So the determinant is of a 2 by 2 matrix is A times D minus B times C, where A is the top left, B is the top right, C is the bottom left, D is the bottom right. So let me just run through what that might mean. Okay, so this zero clue is treating these 4 boxes right here like a 2 by 2 matrix. And the determinant, so this number in the middle is this cell A times this cell D minus this cell B minus times this cell C. So this is A, B, C, D in that order for a matrix. And it's A times D minus B times C. So this cell times this cell minus this cell times this cell is going to equal 0. So basically what the 0 is telling us is that this number and this number have to have the same product as this number and this number. 9 is very big. So this number is going to have to definitely be very small. And one of these numbers is going to have to be a 3 because, or maybe a 6, I guess. But no, it might have to be 3 and 6 actually. It might have to be 2, 3, 6, 9. I think that's probably the only way to get 2, 3. Yeah. So we need, if you factor 9, you get 3 and 3, right? So if these two numbers are going to have the same product as this one and this one, we're going to have 2 3s somehow. And 3 and 6 are the only numbers that have a factor of 3 that are divisible by 3. So I don't know if that math makes any sense, but that's some factoring for you. This is going to have to be, these two numbers are going to have to be 3 and 6. That's the only way we can get the 2 3s and 9, which means that this is going to have to be a 2 because 3 and 6 equal 18, and this is going to be 18. So this one's a 2. This is actually fixed because there's a 3 looking at this one. So this one's 6, this one's 3, and we're off. So now we have -5. So this times this minus this times this is going to have to equal -5. Well, this times this is 1 and 1. That's weird. So 3 times 2 is 6, and this times this has to equal -5. So the product of these two has to equal 1 because 1 minus 6 equals -5, and the only way to multiply to 1 is by multiplying 1 by 1. Interesting. Okay, so 28 is a pretty massive number. So it's this times this minus this times this. So 8's already pretty big. Oh, we have another 0 here too, which is interesting. Huh. Okay. We can actually already do some Sudoku, probably. We have this very filled out box, so 9, 9. There's gonna have to be a 9 here. There's gonna have to be a 2 here. Could this be a 2? Probably. I think these zeros are very interesting, and all of them have 3s on them. So the only way to really do these, so this is to put, you have to put either 9 or 6. So yeah, so I think that seems to be like kind of the key to all of these zeros, because the only way to, so if we have a product of 0, the products, or sorry, if we have a determinant of 0, the products have to be the same, right? So because we're subtracting one from the other and they equal 0. And to subtract 0, you subtract something from itself. So these two numbers multiplied together have to equal these two numbers multiplied together. We have a 9 right here, so there's going to have to be a 6 on one of these, because if they're going to multiply to the same number, there has to be a 3 as one of the factors. So this one is going to be 6, because there's a 6 looking at this box. We knew that one of these had to be 6. So now this number has to be divisible by 2. There has to be a 2 involved because it has to equal 6 or around, and this has to be odd actually, I think, just because of the way factors work. So this number is going to be probably, no, this doesn't have to be odd. Like this could be 4 or 8, and then this could be an even number. So that I was wrong about this having to be odd. But this is probably, this has to be even for sure, and it can't be 2 because that would equal 6. Oh yeah, no, this could be 1. No, it can't be 1. Okay, so this can't be 2. So this is either 4, 6, or 8, and it can't be 6. So it's either 4 or 8. And I don't think that's determined yet. Let me think about what that would mean for this one though. So if this was 4, this would have to be 2, which is impossible. So this can't be 4. So I think it's going to have to be 8, which would make this 24, which would make this a 4. Yeah, and that's going to work out. Okay, so this is an 8, and this is a 4. Determinant stuff. Wow. Okay, 79. So this is definitely 81. So these are 2 9s. 2 9s minus 2 equals 79. So this is a 2, and these are both 9s. Cool. And then we've got a 6 and a 2. So this has to have a 3 in it. It could be 3. Yeah, it has to be 3 and 1. Because this, again, so like because we have a 6 here, there's going to have to be a 3 in one of these because they add to 0. They subtract to 0. So so this is going to be 3 and 1 here because they have to multiply to the same number, and there has to be a factor of 3 involved in this diagonal if there's a factor of 3 involved in this one. So this one is 3, this one is 1. 2 is probably not interesting, honestly. But there must be more Sudoku to do. 3s, maybe not. These middle boxes are like really still very empty. But we have a ton of information in the corners. So what are the 2 numbers that are left in all these? 7 and 4. 7 and 4. I don't think that's decided. These are 5 and 7. There's a 5 here, so this is a 5. That makes this a 7, which is going to decide the other box. Great. What are these 2 numbers? 8 and 7. 7 here. This is a 7. This is an 8. Okay, so I haven't really thought about these at all. So this is a 0, an 8. So there have to be 3 2s between these 2 numbers. So one of them is going to have to be a 4. Yeah, one of these absolutely has to be a 4. 8's tough because 8's factors are 2, 2, 2, right? So that means that there has to be 3 2s as the factors of these 2 numbers together. And the only way to get to 3 2s is to have a 4, and then we're going to need another even number, and the only other even number is 2. So this is a 1 because so it's going to be 4 and 2 on this for sure. And there's a 2 here, so this is a 2, this is a 4, this is a 1 because that multiplies to 8 both ways. Okay, and then we've got 2, so 20 minus 18. So these are going to have to be 8 multiplied to 18. So that's 2 6 or 3, or sorry, 2 9 or 3 6. That's the only way to do that. 2 9 or 3 6. We have a 2 looking at this one and a 2 looking at this one. So it can't be 2 9, so it's 3 6, and it's fixed because there's a 3 looking at this. So this is a 3, this is a 6. And that's almost all the determinant clues. Oh, okay, we can do this one though. 48 minus 20. 6 times 8 is 48 minus the product of these two, which is going to have to be 20. So 4 5. It has to be 4 5, right? Yeah, there's no other way to do that other than 2 10, but we can't put 10 in a box. So 4 5, there's a 4 looking here, this is a 4, this is a 5, and that's all of the determinant clues. Now there's probably just a Sudoku to do. What's this number? Only one left in the column. That's going to be an 8, looks like. Okay, so 8 8, one of these has to be an 8. It's this one. Can we finish the 8s? 8 8, one of these has to be an 8, and one of these has to be an 8. Not quite done with the 8s. Alright, I guess I can just kind of go in order, honestly. If this is a 1. This, we have 1 there. 1, 1, looking down here. I think this is going to be the last one. That's going to do the 8s too, which is phenomenal. Alright, this is probably pretty close to done. Feeling pretty good about the determinant clues. That was all the 1s, right? Yep, 8s are done. Alright, let's go in order. 2s, there's going to be a 2 here, a 2 here, 2 in one of these, and a 2 here. So this is going to fix the 2s. Awesome. Alright, 3s. One of these is a 3. Okay, so 3s don't look like they're super done yet. So one of these 2 is a 3. One of these 2 is a 3. This one is a 3. Okay, there we go. Maybe that'll do some work. So 3, 3. This is going to be a 3, which is going to fix the ones in the top. And that'll set us on our way. 4s. One of these 2 has to be a 4. We got a 4 there. We got a 4 here. And a 4 here. And I think that's all the 4s. 5s. We've got a 5, 5. One of these is a 5. 5 there. A 5. Okay, 5 here, and then a 5 here. Is that all the 5s? I think so. Nope, no 5 here yet. There. Alright, that's all the 5s. 6s. 6, 6. There's a 6 here. 6, 6. There's a 6 there. There's a 6 here. Oh, that was dumb. Okay, one of these has to be a 6, right? Alright, this is a 6, so this is a 6. 7s. 7 here. 7 here. 7 here. 7 here. 7 here. 7 here. These are 9s probably. Excellent. Thanks for watching. Catch you later.